Now, let's move on to some important properties of definite integrals. These properties will make our work much easier when we start computing integrals. Let's go through these one by one. First property, if the upper limit and the lower limit are the same, then the definite integral of f of x equals 0. For example, if you have the definite integral from 5 to 5 of f of x dx, it doesn't matter what the function is. If the lower limit is the same as the upper limit, the definite integral equals 0. This makes sense because there's no width, so there's no area. Second property, the definite integral from b to a of the function f of x dx equals negative of the definite integral from a to b of f of x dx. So reversing the limits changes the sign of the integral. Now, let's look at algebra properties. If we have the definite integral of a sum or a difference of two functions, we can split the integrals. So this equals the definite integral from a to b of f of x dx plus or minus the definite integral from a to b of g of x dx. Next, if we have a constant multiplied by a function, we can pull the constant out of the integral. So we have c times the definite integral from a to b of f of x dx. Now, another very useful idea. If we have a definite integral from a to b of f of x dx and a number c that is in between a and b, then we can split it into pieces. This will be equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx. This means we can break an integral into pieces. For example, if I have the definite integral from 5 to 20 of f of x dx, I can split it into the integral from 5 to 10 of f of x dx plus the integral from 10 to 20 of f of x dx. So you can split the integrals. You can factor out constants. Reversing limits changes the sign. Now, let's move on to the comparison theorem. This helps us understand how integrals compare based on the size of the functions. If f of x is greater than or equal to 0 on a closed interval from a to b, then the definite integral of f of x from a to b is greater than or equal to 0. If the graph is above the x-axis, the integral is non-negative. If f of x is greater than or equal to g of x on a closed interval from a to b, then the definite integral from a to b of f of x is greater than or equal to the definite integral from a to b of g of x. A bigger function gives a bigger integral. If small m and big M are constants, such that small m is less than or equal to f of x is less than or equal to big M on a closed interval from a to b, then small m times b minus a is less than the definite integral from a to b of f of x is less than big M times b minus a. This tells us the integral is trapped in between two values. So the integral behaves like the size of the function. Bigger function implies bigger integral.